Welcome to Conics Parabolas Part 3. Let's take a look at our example. Find the vertex, focus, axis of symmetry, directrix, direction of opening, min or max value, length of the lattice rectum, and x-intercept of the parabola with the given equation. Also sketch the graph of the parabola. Notice that the equation we're provided is 3y squared plus x minus 6y minus 3 is equal to 0. The first thing we're going to do is to rearrange the terms so all the y's remain together, the x's stay together, and the constants remain together. So here we're going to rewrite this as 3y squared minus 6y plus x minus 3 is equal to 0. Now notice that we have a quadratic term in terms of the y's. So let's go ahead and move the x and the constant to the other side. To do so, let's go ahead and subtract x from both sides of the equation and to add 3 to both sides of the equation. Thus, we get the equivalent equation 3y squared minus 6y is equal to negative x plus 3. Now notice that on the left hand side, we can factor out a 3. So let's go ahead and do that. So this now becomes 3 times y squared minus 2y is equal to negative x plus 3. So the next thing is to divide both sides by 3. Doing so will give us the equation y squared minus 2y is equal to negative 1/3 of x plus 3/3, which is equal to 1. Now notice that on the left hand side we have a quadratic expression. So what we're going to do is to complete the square. Recall that in order to complete the square, we want the quadratic coefficient, or the coefficient of the quadratic term, to be 1. So we have an implicit 1 here. Then you want the coefficient of your linear term to be provided. So in this case, we have a negative 2. And the c that will complete the square will be equal to b over 2 quantity squared. And in this case, our b over 2 will be negative 2 over 2. And then we're going to square that. So this is really negative 1 quantity squared, which is equal to 1. So we're going to be adding 1 to both sides of the equation. So this now becomes y squared minus 2y plus 1 is equal to negative 1/3 of x plus 1 plus that 1 that we're adding to complete the square. Now the left hand side will be factored out as follows. We're going to get this one to be y plus or minus whatever we were squaring here. So in this case is minus 1 quantity squared, and this is equal to negative 1/3 of x plus 2. Now I'm going to multiply that 2 by 3 over 3 so we can have the same denominator. So we get the following. We get y minus 1 quantity squared is equal to negative 1/3 of x plus 6/3. Or equivalently, we get the following. Y minus 1 quantity squared is equal to, let's go ahead and factor out the negative 1/3. So negative 1/3 times x minus 6. Now writing down the generic standard form of the parabola, which is y minus k squared is equal to negative 1 or positive 4p times x minus h, we can start to do some matching. And here, if you do the matching, you get the following conclusions. We get that k is equal to 1, the 4p is equal to negative 1/3, and h is equal to 6. Now let's go ahead and solve for p. In order for us to solve for p, we need to divide by 4 on both sides. So we get that p is equal to negative 1/12. But we also are provided with the values for k and h. And remember that your vertex is of the form h comma k. Since we already have those values, we can substitute those in, and we get that the coordinates of the vertex for this parabola happen to be 6, 1. Now, if we do a quick sketch, we can see, okay, the vertex will be 6, 1. So we have 1, 2, 3, 4, 5, 6. and then comma 1. So here is the vertex. And in this case, because we have parabola of the form y minus k quantity square is equal to 4p times x minus h, we know that this is going to be a parabola that opens to the right or to the left. But since p is a negative, this parabola will open to the left. So we can say, okay, here's a quick sketch of the parabola. Now the focus. The focus will be the point here on the axis of symmetry that is 112 units apart from the vertex. So notice that in this case I'm going to take my x value of 6 and I'm going to subtract the 112 in order to get the focus. So I have 6 minus a 12. Now the 6 gets multiplied by 12 over 12, so we get that this is 72 twelfths minus a 12. So that gives me simply 71 twelfths. So the focus will have a coordinate of 71 twelfths, comma, my y coordinate, which is on the axis of symmetry of 1. Now, the axis of symmetry is this particular line here. And that line, it's a horizontal line, so it's of the form y equals a number. What is that number? Well, that happens to be your y coordinate for the vertex. So the axis of symmetry will have an equation of y equals 1 in this case. Now for the directrix. The directrix is this particular line over here that it happens to be p units away, in this case to the right, from the vertex. Now notice that this is going to be a vertical line, so it's going to be given by an equation of the form x equals a number. So what is that number? Well, that number will be your regular x-axis for the vertex plus p, which is in this case the absolute value of p, which will be 1/12. So we take x to be equal to 6 plus a 12, because we're moving to the right. That's why we said plus a positive value. And we said that 6 was equal to 72 twelfths. So we have 72 twelfths plus a 12. That will give you 73 twelfths. So the directrix will have equation x equals 73 twelfths. Now we need to talk about the direction of opening. And based on the equation, we already determined that this was going to open either to the right or to the left. And based on the value for p, which happens to be negative, we decided that the direction of opening will be left. Now, here, our parabola, if you notice, as you go to the right, you will reach a maximum value of x equals 6. So in this case, we can say, okay, we have a maximum, and that occurs when x is equal to 6. So the maximum value here will be equal to 6. The next thing we have to find out is the length of the latus rectum. Recall that the latus rectum, it's the focal chord that happens to be perpendicular to your axis of symmetry. So here's our axis of symmetry, and let's say that here's our chord, our focus, which we should say. So here's the focus, and the chord that we're interested in is this particular chord. That's called the latus rectum. Now, based on the information, we know that the focus will have coordinate 71 twelfths, comma 1. So we want the distance from this point over here to this other point over here. But notice that the x value is fixed, so we're going to fix our x value. So we want the distance between the two y coordinates that correspond to an x value of 71 twelfths. So let's write that down. The length of the latus rectum will be the distance between the y coordinates that have an x coordinate equal to 71 twelfths. So what we're going to do is to copy down the equation that we had previously established, and we're going to substitute in this value for your x coordinate, and we're going to figure out what are the y values. And once we have those y values or y coordinates, we're going to find the distance between them. So the equation we had obtained previously was y minus 1 quantity squared is equal to negative 1/3 times x minus 6. Now substituting in x equals 71/12, we're going to get the following. Y minus 1 quantity squared is equal to negative 1/3 times 71/12 minus 6. And if you multiply this one by 12 over 12 to get the same denominator, we realize that this is going to be 72/12. So you can get the equivalent expression or equation, in this case, y minus 1 quantity squared is equal to negative 1/3 times 71/12 minus 72/12 gives you negative 1/12. Multiplying, you get negative times a negative becomes a positive. You get the following. Y minus 1 quantity squared is equal to positive 1 times 1, which is 1, and 3 times 12, which is 36. So now, in order to get rid of the square, we're going to take the square root on both sides. And that implies that we get y minus 1 is equal to plus or minus the square root of 136. And using the properties of radicals, this becomes plus or minus the square root of 1 over the square root of 36, which is equal to plus or minus 1 over 6. So the two y values that we happen to have are positive 1/6 and negative 1/6. So we want the distance between these two y values. Recall that in order for us to find the distance, we do the absolute value or of their difference. So we're going to take the absolute value of 1/6 minus negative 1/6. And remember that negative times a negative becomes a positive. So you have 1/6 plus 1/6 in absolute value. That becomes absolute value of 2 6s. Simplifying this expression inside the absolute value, we get the absolute value of 1/3, which happens to be 1/3. Therefore, we can say that the length of the lattice rectum is equal to 1/3 units. And the last thing we want to figure out is the x-intercept. Remember that in order to find the x-intercept, we get that y is equal to 0. So again, taking the original equation, y minus 1 quantity squared is equal to negative 1/3 times x minus 6. We substitute in the 0, so we get 0 minus 1 quantity squared is equal to negative 1/3 times x minus 6. And we evaluate this on the left. 0 minus 1 quantity squared is simply 1. So we have 1 is equal to negative 1/3 times x minus 6. We will need to solve for x. Now, to get rid of the negative 1/3, let's go ahead and multiply both sides by negative 3, which is the multiplicative inverse of negative 1/3. Doing so will generate the following equation. Negative 3 equals, this cancels with this, so that is equal to x minus 6. Let's go ahead and add 6 to both sides. So you're going to get simply that negative 3 plus 6 is 3, and that is equal to x. Therefore, your x-intercept happens to be x equals 3, and the coordinates corresponding to that will be 3, 0. So this concludes this video on conics, the particular case for parabolas, part 3. Thank you for watching and have a wonderful day.